We are dripping wet water. In this video, we're going to discuss chlorine dioxide, what it is, why it's the most effective cleaning agent for biofilm removal, where it can be applied, and how the ClO2IX technology produces it safely and efficiently. Biofilm presents several challenges. It is microscopic, hydrophobic, and negatively charged, which helps it resist many traditional disinfectants. It also intermittently and unpredictably releases bacteria back into the water. Most importantly, 80% of all bacteria are contained within biofilms. Biofilm is a big problem. Chlorine dioxide is the best solution and most effective cleaning agent for biofilm removal. Chlorine dioxide is a weak oxidant, a dissolved gas, and remains effective across a broad pH range. Now, let's look at why chlorine dioxide works. One of the most important advantages of chlorine dioxide is its ability to penetrate deep into biofilm structures. Many biocides react rapidly at the outer layer of the biofilm and never reach the microorganisms living deeper within the colony. Chlorine dioxide behaves differently. Because it has no charge and is a dissolved gas, it can move deeper into the biofilm, providing more complete microbial control and helping prevent rapid regrowth. Rather than simply treating the water, chlorine dioxide attacks the source of the biofilm problem by treating the surface. At concentrations below 0.1 parts per million, chlorine dioxide acts as a disruptor for biofilm structure. It weakens the hydrophobic membrane and exposes microorganisms that were previously protected. This disruption allows biocides to actually access the bacteria and kill them. At concentrations of 0.2 parts per million or greater, chlorine dioxide acts as a cleaner. It penetrates deeper into the biofilm and accumulates along the pipe surface. By breaking the bond between the biofilm and the surface, it causes the biofilm to detach from the surface. At concentrations of 0.3 parts per million and above, chlorine dioxide acts both as a cleaner and a biocide to kill the bacteria within the biofilm. Because it has already penetrated the biofilm, it can directly contact and kill bacteria embedded deep within the biofilm matrix. Although chlorine dioxide is extremely effective, generating it can get challenging. Because chlorine dioxide is unstable, it is often generated on site. High concentrations require additional safety precautions. Many generation methods create unwanted byproducts that can increase corrosion or reduce product quality. Despite these challenges, chlorine dioxide offers tremendous advantages. So the question becomes, how do we keep all the advantages of chlorine dioxide while eliminating the challenges associated with producing it? That is exactly what ClO2IX was designed to do. Our technology controls each step of the chemistry, producing a high-purity, low-concentration chlorine dioxide solution on demand in a safe and efficient manner. The first step is converting sodium chlorite into chlorous acid. Sodium chloride itself does not readily generate chlorine dioxide. However, chlorous acid is the chemical species that can be converted into chlorine dioxide. By isolating chlorous acid first, we separate the chemistry into controlled steps instead of allowing one uncontrolled reaction. Our single precursor process accomplishes this conversion using ion exchange technology. Water and sodium chlorite pass through the cation 9 resin, where sodium ions are exchanged for hydrogen ions, forming chlorous acid inline. Because the process relies on ion exchange, no excess acid remains in the solution. It also accommodates varying feed water alkalinity while producing a pure chlorous acid stream ready for catalytic conversion. We also offer a double precursor process using chemical mixing. Sulfuric acid reacts with sodium chlorite to generate chlorous acid. When properly controlled, this process minimizes chloride formation and reduces corrosion concerns while still producing a high-quality feed for the catalyst. Once chlorous acid has been produced, the second step is catalytic conversion. The catalyst provides a new reaction pathway while lowering the activation energy of the reaction to provide high conversion at low concentrations. This allows chlorous acid to convert efficiently into chlorine dioxide while maintaining excellent reaction control. This slide shows the complete single precursor process. Water and sodium chloride enter the system. The ion exchange stage forms chlorous acid. That chlorous acid immediately passes through our proprietary catalyst, producing a chlorine dioxide solution of approximately 700 milligrams per liter. Every stage is carefully controlled to maximize conversion while maintaining safety. The double precursor system follows the same overall concept. Water, sodium chloride, and sulfuric acid first generate chlorous acid. That chlorous acid is then converted across the catalyst into chlorine dioxide. Depending on the system, concentrations between approximately 700 and 1,650 milligrams per liter can be produced. ClO2IX generation systems utilize a safe and controllable reaction to produce a high-purity solution at low concentration and high conversion efficiency, producing no chlorine that can result from traditional 2- and 3-part generation technologies, and no ozone that can result from electrochemical processes. By eliminating many of the traditional drawbacks associated with chlorine dioxide generation, ClO2IX delivers a high-purity solution specifically designed for biofilm control and water treatment. Our patented catalytic technology makes ClO2IX suitable for a wide range of industrial applications. Biofilm exists across the entire water industry. All applications are vulnerable to biofilm fouling. By removing biofilm at its source, facilities can eliminate heat transfer resistance, restore flow, reduce maintenance, protect equipment, and maintain cleaner water systems. Many water treatment programs focus on treating the water, but the real problem is the surface the water is flowing through. You can produce perfectly clean water, but if it travels through pipes covered in biofilm, that water is immediately exposed to contamination. With ClO2IX chlorine dioxide, you can break the biofilm cycle and prevent contamination of the system. Thank you for watching this video. To learn more about biofilm and ClO2IX technology, please watch our other videos. Always remember, don't run clean water through dirty pipes.